perfect cubes are, perfect squares. How do you find perfect cubes? You start with the smallest number and raise it to the what power? Third. So the smallest perfect cubed is, no, it's 8. Good. 2 cubed, 2 is not a perfect cube, meaning that you can't cube any number to get 2. But 2 cubed is what? 8. Just like if I said, what's the smallest perfect square? You wouldn't tell me 2, right? You would tell me what? 4. Does everybody understand? Okay. Alright, so when you're solving exponential equations, you're really solving for this exponent, right? Solving for n. But notice that, or excuse me, solving for the letter n, but it's an exponent. And what you have to do is you have to make these be the same base. And when I say base, what's the base of this side? 4. What's the base right here? 64. We want them to be the same base, and when they are the same base, you can set their exponents equal to each other and then solve for n. Alright, so the trickiest part is just finding a number that you can raise to a power to get both of these numbers. Okay, so if you're thinking 4, we could raise what number to what power to get 4? What now? 2 to the what power? 2. 2 squared is what? 4. Alright, so instead of writing 4, let's rewrite this as 2 squared instead of 4. So again, I'm just replacing 4 with 2 squared, because aren't they the same thing? But we can't get rid of this exponent, so in parentheses beside this 2, I'm going to put 2n minus 1. I'm just going to carry it down. Again, the 2 squared comes from 4. Alright, is there any number that we can raise 2 to, like a power, to get 64? 8? 2 to the 8th power is 64? Alright, everybody check it. Make sure he's right. Okay. 2 to the 6, everybody check her. Make sure she's right. 2 to the 6 is what power? Or is what? 64. I think you're thinking of 8 squared, Zach. You can raise 8 to the 2nd power and get 64. I get what you're saying. But if you raise 2 to the what power, you get 64. And now notice how they have the same base. They both have a base of what? 2. So now we can set the exponents equal to each other and cancel out the bases. So here's what that would look like. We'd have 2 times 2n minus 1 equals what? 6, this exponent. And now we just solve for n. So how would we do that here? Distribute the what? 2. We could do that, or Dylan says we could divide both sides by what? 2. Either one. Yes, Zach.
The whole cube times 2 and minus 1 equals 6. That's all the exponents, right?
Yes. Yes, sir. So do y'all want to yes.
Why do the 2's cancel out?
Because they're the same base. So this would be the same as, like, 2 divided by 2 is just 1. Like, they would cancel out. They just have to be the same base in order for us to do that. We couldn't cancel out 4 and 64. Alright, would y'all like to divide by 2 or distribute it? Divide, distribute? Okay, divide. So if we divide, what we get on the left side? 2n minus 1. These 2's cancel out. 2 divided by 2. We're left with 2n minus 1 equals 3. And now we would add 1, so we get 2n equals 4 and n equals 2. We have solved for n. That's it. So if you wanted to check these, you could plug 2 back into the original. Hold on one second, Zach. Jack, sorry. So 2 times 2 would be what? Minus 1? So 4 to the 3rd power would give us 64. And that does check out. Yes?
Where did you get this 6 from?
This part?
Yes.
From this exponent. And how we got 2 to the 6 is we were looking for the same base. So once we chose 2 squared, we had to figure out a number we could raise 2 to get 64. So 2 to the 6 is 64. That's where we got the 6 from.
Were you trying to find the base?
Yeah, they have to have the same base in order for us to cancel them out. Any other questions? Okay, for the next one, what do you think our base is going to be? Good, 3. So that means that this is 3 to the first power. So will the exponents change or anything? No, because even if we put 3 to the 1 times 5x would just be what? 5x. So 3 to the 5x. We'll have to change this 27, though, to 3 to the what power? Good. And remember, don't change your exponents, bring them down. And again, the reason I got 3 to the third is because 3 to the third is 27. Now they have the same base, so we just set the exponents equal to each other. So this would be 5x equals 3, 2x minus 4. What would y'all like to do first? Distribute 3? Okay. So we get 5x equals what? Now what? Okay, we could add 12 to this side, but that doesn't help us get x by itself, right? So subtract 6x, so we get what?
Negative x.
Equals, and so x equals just 12. Very good. Yes?
If you're trying to get them to have the same base or whatever,
Mhm.
how come like you brought down 5x instead of 3?
Because this is 3 to the first power, so I could rewrite this as 3 to the first power times 5x, but that's the same as what? Just 5x, right? This already has a base of 3, so we don't have to change the exponent. This one doesn't, so we have to change this exponent of 3, so 3 cubed can give us 27.
But your bases like ultimately just cancel out.
Yes.
You get them to be the same.
Yeah, same thing as 3 divided by 3 would just be 1, so they just cancel out. We just have to make sure we get them the same. Any other questions? Alright, what would our like or similar base be in this one? 7. So we need to change this to what? Tell me what else to write. Good. Tell me what to write over here. 7. Good. We don't have to change that one because it already has a base of 7. So our bases will cancel, and we'll have what on this side? Equals 8x minus 6. What do y'all want to do first?
Plus.
Okay, distribute 2. We could plus 6, Seth, but we couldn't add it until we distribute this. So it just... Oh, okay. Gotcha. So 2x plus 10 equals 8x minus 6. Now what? Alright, I'll add 6 since I heard that the most. So 2x plus 16 equals 8x. Now what? Minus 2x. So we get 16 equals 6x, and then divide by 6. And let's go ahead and simplify. So what is a number that goes into 16 and 6? Alright, how many times on top?
8.
And on bottom? 3. Very good. Any questions about that one? How do we feel about them so far? Easy? Okay, good. Alright, next one. Has a fraction in it. Before we even start, why would it have a fraction? What does that indicate? It had a negative exponent. Yes. The x from? Oh, from right here. We took 2 out of both of these. So 16 divided by 2 is 8. 3 or 6 divided by 3 is 6 divided by 2 is 3. Good. Perry's exactly right. If it has a fraction, that means it had a negative exponent at one point, right? For example, don't write this down, but 2 to the negative third power. If I wanted to rewrite that, that would be what? 1 over 2 to the third. Good. To make it positive, you move it on bottom, right? And a 1 goes on top. And what is 2 to the third? 8. So 1 over 8 and 2 to the negative 3 are the same thing, right? Everybody see that? Again, because we had to move it on bottom because of negative exponent. And then 2 times 2 times 2 is 8. And then 1 stays on top.
Do we have to get it back to the negative exponent?
Yes, you do. So, for example, don't write this part down, but 1 over 64. Just imagine that it's 64. Not 1 over 64, just imagine it's 64, okay? And the base is 4. Can we raise 4 to any power to get 64?
Yes.
What did we raise 4 to get 64? 3, right? Or we could use 2. We could use a base of 2 or 4. Doesn't matter, because they both, you can raise both of them to a power. But let's go ahead and use 4, since we already have it here. Alright, so again, what can we raise 4 to get 64? 3. So 1 over 64 is 4 to the negative 3. You just make it negative. Does that make sense? Okay, let me go back over here. So, do I have to rewrite this one? No, I can just leave it as 4, 2x minus 5. Again, if you use 2, that's fine. You'll get the same thing. And then this would be 4 to the what power? Very good. Alright, so now we set them equal. So we'll have 2x minus 5 equals negative 3. And then we do what? Add 5, so we'll get 2x equals, so x equals, very good. Questions? Okay. Alright, for the next one, what do you think our base is going to be? 3, very good. So tell me what to write for this first one. Perfect. Oops, sorry, my parentheses ran a little long. This would be 3 to the parentheses. Perfect. Any questions about how we got that number 3? Okay, so the exponents would look like this. 2 negative x plus 5 equals 3, 6x minus 10. What do y'all want to do? On both sides? So we'll get what on this side? Plus equals. Good. Do y'all want to combine your x's or whole numbers? Okay, so what do you want to move? Okay, so we add 2x both sides, and we'll get 10 equals what? Alright, then we'll have to move the 30 by adding it, right? So we'll get what equals 20x? And so x equals? Very good. Aren't these fun? Yeah. They're not bad at all. It's like a puzzle piece. Alright, the rest of it you'll be working on your own, and it's 3 like we did yesterday, so the people who weren't here, I'll be with y'all to help y'all. And then the 1 through 6 is just like we did today, but I will let y'all pick one of the ones from 1 through 6 to work together. Yes?
You know, like on your last line of word, like where it says negative 2x plus 10 equals 18x minus 30.
Yes.
How do you know which to like do first?
Oh, it doesn't matter. As long as
I worked
you...
it down and got negative 2 because
Did you add... What'd you do first from here?
like when I subtracted 18x instead of adding 2x.
Okay, so if you subtracted 18x over here, you get negative 20x, right? Equals... Or excuse me, you have negative 20x plus 10 equals negative 30, right? Okay, then from here you would do what? So you get negative 20x equals, yep, and then you divide negative 40 by negative 20 and get, yes, you get the same thing. All right, any other questions? Yeah.
So the graphs on this sheet, that's what we did yesterday, right?
Yes. And you don't have to put if it's growth or decay, just graph it and then tell me domain and range. All right, is there any ones from 1 through 6 that you want to do together? Or are y'all okay to do these on your own?
So we just got the rest of this for that's what we're doing the rest of the time?
Yes.
Okay.
5.
Yes. And it says it's for homework, but you should be able to finish it in class. It's pretty quick.
Can we do 7 and 8?
What now?
7 and 8?
7 and 8 on the bottom?
Yeah.
All right, I'll do one of those. So 5, 7, or 8. Which one?
It doesn't matter.
No, we do 5. I'm asking, because you said 1 through 6, but do we also do 7 through 8?
Oh, yeah, you do the whole thing. I'm sorry if I said 1 through 6. Okay, so on number 5, what do you think our like base would be? Okay. Can you raise 4 to anything to get 8? Good. So it has to be what? 2. Okay. So this would be 2 to the what power here? Good. So tell me how to rewrite this side.
2 to the 3rd x minus 2.
Perfect. All right. Ignore the 1 over 16. Just think of 16. What do you have to raise 2 to get 16? 4th. So it would be 2 to the negative 4th. Good. And now we set them equal. So this will be 3x minus 2 equals negative 4. Do y'all want to distribute first? Okay, so we'll have 3x minus 6 equals negative 4. Now what? So we get 3x equals 2. So x equals 2 over 3. This is probably the hardest chapter